Hi everybody, welcome to today's lesson on formal fallacies. Today we'll be discussing denying the conjunction. In this short lesson, we'll first take a look at a few examples of how denying the conjunction is employed in natural language as a means of argumentation. Then we'll take a look at its propositional form, and finally we'll take a look at a proof of its invalidity. So let's get right into it. How is this formal fallacy employed through natural language? We have a few examples here ahead of us. The first one starts with premise 1, and imagine, if you will, that we are at a restaurant. Premise 1 proposes, I will pay by cash, or I will pay by card. Premise 2 proposes, I will not pay both by cash and by card, and we conclude that I will therefore pay by cash. Now, it's pretty intuitively simple to tell that this is unsound reasoning. Just because I have a choice between whether or not I will pay by cash or by card, and I say that both choices will not be the case, it doesn't entail that I will indeed pay by cash. The second example starts with premise 3. Plato was a philosopher, or Plato was not a philosopher. Premise 4 proposes that Plato was not both a philosopher and not a philosopher, and we conclude that therefore Plato was a philosopher. And the third example starts with premise 5. Lizards are not mammals, or lizards are not reptiles. Premise 6 proposes it is not the case that lizards are not mammals and lizards are not reptiles, and we conclude that therefore lizards are not mammals. Let's now take a look at the propositional form of this argument. If you recall each example, each one starts with a first premise that proposes a disjunction, right? We have P or Q, this or that. Premise 2 proposes that the conjunction of those two disjuncts is not the case, and we conclude that therefore one of the disjuncts is true. In order to get its propositional form, we'll take these two first premises here, and we'll make a conjunction out of them, and we'll take our therefore symbol, and we'll turn that into implication. And now we have to ask ourselves, is this propositional form true in every interpretation? In order to do that, let's move over to Excel and fill out the truth table that we see here. This is just the skeleton of the truth table. All we have to do is punch in our values to figure out whether or not this form is valid. And since we only have two propositional variables, we know that we will have four possible interpretations. That is, one in which P is true and Q is true, one in which P is true and Q is false, one in which P is false and Q is true, and one in which neither P nor Q is true. And let's copy that over to our other columns while staying consistent. Now let's take a look at column B. This is our disjunction operator, and we know that the disjunction operator returns a value of false if and only if neither of the disjuncts is true. If at least one of the disjuncts is true, it will return a value of true. In our first interpretation, both disjuncts are true, so we will have a return value of true. In our second and third interpretations, at least one of the disjuncts is true, so we will have return values of true there as well. And in our last interpretation, neither of the disjuncts is true, so we will have a return value of false there. Now let's take a look at column G. This is our conjunction operator, and we know that the conjunction operator returns a value of true if and only if both conjuncts are true, otherwise it will return a value of false. In our first interpretation, both conjuncts are true, so we will have a return value of true. In our second and third interpretations, only one of the conjuncts is true, so we will have a return value of false for both of those. And in our last interpretation, neither of the conjuncts is true, so we will have a return value of false there as well. Next, let's take a look at column E. This is our negation operator, and we know that the negation operator will just return the opposite value of what we see here in column G. So where we see a 1, we'll punch in a 0, and where we see a 0, we will punch in a 1. Next, let's take a look at column D. This is also a conjunction operator, and keep in mind here that we will be comparing column B and column E. In our first interpretation, we have one true conjunct and one false conjunct, so we will have a return value of false there. In our second interpretation, we have both true conjuncts, so we will have a return value of true there. Same thing for our third interpretation, and our last interpretation, we have a false conjunct and a true conjunct, so we will have a value of false there. And finally, let's take a look at column J. This is our material implication operator, and we know that the material implication operator returns a value of false if and only if the consequent is false and the antecedent is true. And keep in mind that we will be comparing column D with column J. In our first interpretation, our antecedent is false and our consequent is true, so we will have a vacuous truth there. In our second interpretation, our antecedent is true and our consequent is true, so we will have a return value of true there. In our third interpretation, we have a true antecedent and a false consequent, so we will have a value of false there. And in our last interpretation, we have a false antecedent and a false consequent, so we will have a value of true there as well. And there you have it. We can see that this form is indeed invalid. That's the lesson for today, everybody. Thanks for coming by, and until next time, may reason be with you.